Hello viewers, and welcome to today's video about how to do stoichiometry. We'll not only be learning how to do stoichiometry, but how we use it in the world around us. So let's start off with a simple question. What is stoichiometry? Well, the definition of stoichiometry is a branch of chemistry that deals with the application of the laws of definite proportions and of the conservation of mass and energy to chemical activity. For everyone who doesn't know what that means, it merely refers to the relative proportion of components within a reaction. Now let's get into how stoichiometry works. Now before I get into this topic, we all know that one guy in class who said, Mrs. Teacher Lady, when are we ever going to use this in the real world? Well, for you teachers out there, here's what you say. Well, John, stoichiometry may not always fall into real-life scenarios, but its ideas can fall into a variety of subjects. Like what? Well, think of your math class. When you use dimensional analysis, only a certain amount of units can go into another unit. And? It's just like stoichiometry, John. You use proportions to figure out how much of that certain substance you have. I guess you're right. Of course I'm right, John. Now let's get into how to do a stoichiometry problem. Here are a few of the main steps to solving a stoichiometry problem. Now I'm going to pass it off to my colleague, and he's going to do an example with you guys using the chemical reaction formula of the carbon-zinc battery.
The balanced chemical formula of a reaction in a carbon-zinc battery. What is the greatest amount of manganese 3 oxide in grams that can be made with 0.15 moles of zinc, 0.23 moles of manganese dioxide, and 0.14 moles of ammonium chloride? What is the limiting reactant? As the question is asking for the limiting reactant, we have to solve the amount of product for each reactant in the formula. Starting with zinc, I want to convert this into moles of manganese 3 oxide. So I multiplied by 1/1 because for every mole of manganese 3 oxide there is 1 mole of zinc. Next, I want to convert this into grams of manganese 3 oxide, so I multiplied by the molar mass. This would give me 23.6805 grams. Next, for manganese dioxide, I want to convert this into moles of manganese 3 oxide. I would convert this into manganese 3 oxide in moles, so I multiplied by 1/2. Next, since the question is asking for it in grams, I would multiply by the molar mass of manganese 3 oxide. This would give me 18.1551 grams. For ammonium chloride, I will multiply this by 1/2 because for every 1 mole of manganese 3 oxide, there are 2 moles of ammonium chloride in the equation. That it is in moles, I can multiply this by 157.87 grams and convert it into grams of manganese 3 oxide. This would give me 20.5231 grams. Now that we have these numbers, we can determine the greatest amount of manganese 3 oxide in grams that can be made, and we can also find the limiting reactant. The greatest amount of manganese 3 oxide that can be formed is the smallest number that we got as our answer, so that would be 18.1551 grams of manganese 3 oxide. Since this is made from manganese dioxide will be our limiting reactant.
And that's all, folks.